Hey everybody, in this video we're going to be looking at if-else statements and exploring how we can use that as a control structure in some of our programming with Arduino. On my breadboard I've got set up a really simple little example here. I have a button which is a digital input connected to pin 2 on my Arduino. I have an RGB LED and the channels of that LED are connected with red to pin 3, green to pin 6, blue to pin 9. And I have it programmed so that when the button is not pressed, so the digital input reads 0, the LED is cyan, and when the button is pressed, it turns red. Let's build out the code for that and look at how if-then statements or if-else statements might be used to support this experience. Zip into here, start working out our program. It's always a good idea to have comments in your code to indicate what the program does, so I'm going to throw a couple of comments at the top here. Now, we've seen this in class, so we know that both of these circuits we need to make some pin declarations. We need to tell the Arduino where is the RGB LEDs, so I'm going to just create those variables really quick. And we're going to need 2 variables for the button. And as always in setup, we're going to need to define our pin modes for all 4 of those circuits, RG and B, and the button. Quick reminder, all 3 RGB pins are outputs. Button pin is an input, so it's going to send current into the Arduino, output send current out to the breadboard. With all of that out of the way, we can now get into the heart of the program that we're exploring and start to develop some code that's going to control this RGB LED with the button. First thing we obviously need to do is read the state of the button. So the button state is going to be, and a button is a digital device, and we're working with an input, so we're going to read the state of the circuit. And the circuit has to be, we have to tell Arduino where to find that circuit, so we're going to read the button pin. So button state is a variable, and it's now going to hold either a 0 or 1 because it's digital, depending on whether or not the button at button pin is pressed or not pressed. When it's pressed, it's 1. When it's released, it's 0. Now, let's set up our if statement. And what we're going to say if button state equals 1, and note that there's a double equal sign here in Arduino. That means comparison. So this says if the variable button state is equal to the numerical value of 1, then let's take some action. And I'm going to put in the braces for that action right away, and I'm just going to say end if right here so that we don't confuse that with this guy down here, end loop. And now we can put the code that's going to execute when the button is pressed. And in our comment at the top, we said button pressed, we're going to give ourselves a red. So let's start with that. The button is pressed. So if this condition is true, the code inside those braces is going to be executed. And the code we want is this time a digital write. We're going to send electrical current from the Arduino to the breadboard. And where are we going to send it? We're going to send it to the R pin because we want to make our LED glow red when we press the button. And we need to set the voltage on that pin to a high or a 1, which equals 5 volts. And that should turn red on. We need to also code what happens to this LED when the button isn't pressed. If we stopped right now and upload the code, and it actually might be worth just doing really quickly, let's upload and see what happens. And now it's uploaded. We can look at the circuit. LED is off, button is released. That seems pretty good. I press and hold the button, it's red, that's awesome. And I let go of the button, it's still red. Well, that's not what I wanted. Why is it still red? Well, I come down here and I look at what's happening. Loop is happening over and over and over again. I read the button effectively, that's clear because I turned it red. When the button state is 1, we told it to turn the LED on, which it did. We never told it to turn the LED off when we released it. So we need a second if statement here to see if we can make our LED turn off when we release it. Releasing the button it's a digital input again, is going to happen when button state goes to 0. So when I release the button, right now, button state is reading 0. And this time I'm going to do digital write R pin 0. Save and upload that this time. And our code should be in, hold the button down, red, release the button, off. So now we at least have a really good chunk of this code done. We've seen that if we don't complete conditionals for the two different states of the button, so if we don't have an if statement for when it's on and when it's off, we might not get quite the behavior we're looking for. We have to remember that the conditional part of any if statement, so the if statement is combined with the if declaration, a conditional statement, button state equals 0, and there's different comparators. You can use equal to, greater than or equal to, less than or equal to, and one that's not obvious, you can always say not equal to. There's really good moments when you might want to say, if this is not happening, let's do this other thing. If the condition is true, the code here is going to execute digital write LED off. Behaviorally, this looks a lot like an example we developed in class where we simply wrote the button state into the digital write. So instead of putting a 1 here, we just put button state and skipped a whole bunch of lines of code. And that worked great when we just wanted to have the LED connected to the button to prove that we were pressing it. But we've created this challenge for ourselves that when we release the button, we want cyan. And to get that, we need to do a little more work inside the second if statement. If the button is 0, we don't just want red off, we want blue and green on a little bit. And to do that, we need to use an analog write. And we're going to analog write the green pin. And I'm just going to turn it on halfway. And we're going to analog write the blue pin. And we'll turn it on halfway as well. You can play with different numbers other than 127s here. But remember, the number range for an analog write is 0 to 255. And 127 falls right in the middle of that range. So that's roughly half on. And this one's half on too. Let's see what happens now if we fire up this code and give it a shot. So we'll save and upload. I'm not pressing the button. I've got a kind of cyan-y color, so that certainly covers that part of the challenge. I hold the button down and I've got white. Who coded white? I didn't code white, did I? Let's go back, look at this code. First time through the loop, we read the button. The button state is 0 because the button isn't pressed. We come down to here then. If the button state is equal to 0, which is the case when we haven't held it down, then we're going to digital write red off. That's good. And we're going to write green and blue halfway, and we get cyan. That's what's expected. That's good. Awesome. We come around now, and I press the button down, and my button state becomes 1, and I digital write the red pin to fully on, but blue and green are also still on, and if you mix all three colors together, you get white-ish with an RGB LED. So now I realize, oh, I need to do a little more work here. I need to turn the green and the blue pins off. Upload that. And hold my button down. And now I have the behavior that I was looking for. So if statements on their own are very straightforward. If conditional is true, if it is true, execute the block of code inside the braces. We've seen two examples though in this little demo of how not having your conditionals fully thought through can create some weird behavior. In the first case, we only had a conditional for when the button was pressed, and that left the LED on all the time. And as we just saw, if we don't turn off the other colors as we're alternating states, we might get some unexpected colors, such as cyan and white instead of cyan and red, which was the goal of this little bit of code. One quick variation on this. because the button is a digital device and it can only be 0 or 1, we don't actually have to write two complete if statements. You can use a slightly different structure between these, which is called else. And the way this block of code works is if this first guy is true, button equals 1, do this thing. Otherwise, for every other moment that the button isn't 1, else, do this thing. Let's upload that for a second and talk our way through the code. Works exactly the same way as the two if statements. And that's because our button is digital. It can only be a 0 or a 1. So in the first case, if the button is 1, it must be pressed. Execute the first block of code right here. Otherwise, else, execute. So all the other times when you're not pressing the button, execute the highlighted block of code here. Taken together then, the if and the else give us two different conditional states, and we can encode two different colors into our LED. Notice that I'm mixing digital and analog writes quite freely. You can be quite flexible in code here once you have your circuit set up, which is a really nice feature of this space. We'll explore some other ways to control your RGB LED in different videos, but that really brings us to the end of this introduction to if and else statements.